Hey everyone, and welcome. Today, we're going to tackle a really common code smell, the anemic domain model, and transform it into a robust, rich domain model using some key ideas from domain-driven design. Let's get right into it. All right, let me ask you something. Have you ever jumped into a project and realized the core business rules are, well, everywhere? Maybe they're buried deep in some service class or spread across these massive command handlers, making the code just a total nightmare to understand and maintain. If that sounds even a little bit familiar, you are definitely in the right place. So what are we even talking about here? Well, on one side, you've got the anemic domain model. This is where your entities are basically just glorified property bags, just dumb containers of data. All the smarts, all the behavior, lives somewhere else entirely. But on the other side, you've got the rich domain model. And this is where the magic happens. The data and the behavior live together, side by side. The entities themselves are actually smart. They're responsible for their own logic and for protecting their own state. Okay, so here's the game plan for today. First, we're going to diagnose the anemic problem using a sample app. Then, we'll talk about what it takes to build a rich domain. After that, we'll jump into a couple of hands-on refactoring examples. And finally, we'll wrap it all up by talking about why this approach is just so powerful. All right, let's kick things off with section 1. I want you to meet our patient. It's a simple little event management app called Gatherly. And this is going to be our before picture, a perfect example of a classic anemic domain. So the concepts in this app, Gatherly, they're pretty straightforward. You've got a member, that's just a user. A member can create a gathering, an event. They can then send out an invitation for that gathering to other members. And once someone accepts, we track them as an attendee. Simple enough, right? Okay, now look at this. What's really telling here is what you don't see. This is our gathering entity. And notice, it's just a bunch of properties with public setters. There are no methods, there's no behavior, no logic whatsoever. It's a textbook anemic entity. A data bag. It does nothing. So where's all the logic then, right? Where does it live? Well, it's all crammed into this create gathering command handler. All the important business rules about what type of gathering it is or how many people can attend, none of that is in the gathering class itself. And this is the absolute core of the anemic problem. The logic is totally disconnected from the data it's supposed to control. Okay, on to section 2. So how do we actually fix this mess? The answer, and it's a core idea in DDD, is to push all that behavior down, get it out of the application layer, and put it into the domain entities, right where it belongs. And the magic word here, the core principle that lets us do this, is encapsulation. And look, this isn't just some academic term. It's our #1 tool for this job. It's all about bundling the data together with the methods that change that data. And this is the crucial part. We restrict direct access to the object's state, which means the object can protect its own integrity. It can never be in an invalid state. All right, enough theory. Let's get our hands dirty. In section 3, we're going to do our first refactor, and we'll focus specifically on how a gathering gets created. So here's exactly what we're going to do, step by step. First, we'll add a static factory method right on the gathering entity called create. Then, we'll take all that creation logic out of the command handler and move it inside this new method. Next, we make the constructor private, so nobody can bypass our new factory. And finally, we make the property setters private to completely lock down the object's state. And boom, look at the result. Our command handler is now ridiculously simple. All it does is call gathering.create and then asks the repository to save the new gathering. Its only job now is to be a traffic cop, to orchestrate the flow. That's it. And the star of the show, the gathering entity, is completely transformed. It's not a passive data bag anymore. It's now in total control of its own creation, making sure every single business rule is followed. And those private setters mean no one from the outside can mess with its internal state. It's now an active, intelligent object that's actually responsible for itself. Okay, let's keep this momentum going. Section 4. This time, we're going to tackle something a little trickier, sending invitations. This gets interesting because it involves managing a whole collection of objects. You have to start with this core idea, this design principle. The gathering is the owner of its invitations. It just makes sense, right? So if that's the case, then it follows that the logic for creating and managing an invitation should live inside the gathering entity itself. You see this all the time, right? A public list of something on an entity. That means anyone can just come along and call .add or .clear on that list, totally bypassing any rules you might have. The fix is to expose it as a read-only collection instead. That way, the only way to add an invitation is to call a specific method on the gathering entity, and we stay in complete control. And you'll notice the pattern here is pretty much the same as before, which is great. It's a repeatable playbook. First, we create a new send invitation method right on the gathering entity. Then, we move all the logic for validating and creating the invitation into that new method. And finally, we protect that collection so it can only be changed through our new controlled method. And again, look at the payoff. The command handler is just beautiful. All it does now is find the gathering, find the member, and then tells the gathering object, hey, you, send an invitation to this person. All the tricky logic is hidden away, perfectly encapsulated inside the gathering entity. All right, we're in the home stretch, section 5. We've done all this work, but let's step back and ask, why does any of this actually matter? What's the big win? Honestly, the benefits are massive. First off, your business logic is all in one place. You know exactly where to look when you need to change a rule. Second, your entities actually protect themselves. They can't be put into an invalid state. This all leads to code that is so much easier to maintain and for new people on the team to understand. And your application layer becomes what it was always meant to be, a thin coordinator, not a dumping ground for business rules. So, if you only remember one thing from this whole explainer, make it this. A rich domain model fundamentally changes your code. Your classes are no longer just these boring Anemic data bags. They become living, breathing objects that actually have behavior and truly represent the concepts from your business. But, and there's always a but, right? It's not always that clean and simple. This is all great for logic that lives inside our neat little world, but what happens when we have to talk to external systems, like an email service? So picture this scenario. It's a classic. A member accepts an invitation. Our internal domain logic works perfectly. Step 2, our database save is successful. Everything is consistent inside our system. But then in step 3, we make a call to an external service to send an email notification, and that call fails. And that leaves us with a really tricky problem, doesn't it? Our database is perfect. It says the invitation was accepted. But the email, it never went out. The real world doesn't match our database. So what do you do now? It's a tough question, and a great reminder that building truly robust systems is always an ongoing challenge. Thanks for watching.